I was chatting with a chap called Ben Summers, who I know a few of you know, on Twitter, and he pointed out that every single dongle-based technology, like HDMI cables from projectors and stuff, are now infectable by everything. So whiteboard, definitely not infectable by a virus. Is this working? I can't tell if this is working. Probably. The title of this talk was Balancing Infrastructural Debt. I have no idea if that's what it's about. I wrote it yesterday. I revised it on the way over here. Let's see how it goes. Questions are very much welcome. If you talk forever, I'm looking at you, Sandro, then I will cut you off. And it probably will last somewhere between 15 and 20 minutes if you don't have very long questions. And if you do, it could last all night. Let's see how it goes. So here's how infrastructure works. So you've got some developers, right? Right. So this is a developer, and he's got a computer, and he types some code, and then the code goes over here somewhere, and then it gets compiled by a box somewhere, probably on his developer's machine, because let's face it, no one has CI. So it gets compiled by a server or something, and then that makes a little binary, and that gets thrown over a wall. Here's a wall. All right, and then there's another person over here who's got another computer, looks very similar but way older because no one invests in their ops people. And then this person takes this code and puts it on another server and then maintains it until the end of time. Okay, and then of course that's really unfair because there's another person here and they call first line support and they have to figure out what the fuck you were thinking whenever something goes wrong or there's weird things in the logs, and that is assuming you have logs because you probably don't. So, I mean, who works at a place like this? Really? Half of you are lying. Yeah, so half of you are lying. Yeah, that's a better question. Who's ever worked at a place like that? Wow, you all have much better jobs than you used to. That's really good to hear. So I'm guessing you've all heard the magical word DevOps, and what DevOps mean is now you have to do your job. So instead of you throwing this over a wall, there is no wall, and that's you. That's what DevOps is. And that's not to say that we don't have someone who knows how your infrastructure works, but you should also know how your infrastructure works. And I think part of it, the DevOps movement, as much as it does feel like a buzzword of the year, part of it is you should understand the infrastructure you're deploying to, and you should build software that deploys to actual real hardware rather than the mythical computer in the sky, or Amazon, as some people call it. So, turns out DevOps is hard. So let me give you some examples. Okay, you wrote some code. Where are you going to deploy it? I bet you didn't think of that before you wrote the code. Or let's say you did, right? And then you wrote this thing and you go, oh, microservices are cool. I'm going to take my monolith and I'm going to split it into a few services. Good. Now, how are you going to version them independently? How are you going to deploy them independently? What happens if one goes down and the others need to communicate with it? Let's say you publish your code to a registry, kind of like something like Maven or NPM or Ruby Gems equivalent. How are you securing that? Let's assume it's not on the cloud because cloud's cheating. And how are you making sure that no one else can access your code? It's like the same thing. If you're pushing your code to a Git repository that you're hosting yourself, where are you pushing it to? I need to refer to my notes because I have no idea what I'm saying. Let's see. So let's say you set up a server. Like you've got a server, right? You set up your server. Even if you're running it in the cloud, even if you're using EC2, where are you backing up your data? Right? I assume you have data on there somewhere. Otherwise, you probably have a meaningless product. No, that's not true. You might not have data, but most products do. Let's see. If you are storing user data, how are you making sure that everything is secure and people aren't going to hack into your server and take it down or steal all your data, take all your identifiable user information, and allow your users to sue the shit out of you? What if you change your API? How are you going to migrate all of the clients that talk to your API? I've got so many more of these. I could keep going forever. I probably shouldn't. How are you going to deploy without downtime? Let's say you modify your service. Let's say it's a pure refactoring or a performance improvement, so there's no breaking changes. How are you going to deploy it without everyone getting really annoyed that you were down for even 30 seconds? Let's say you put your software into Docker and pretended like that was going to solve all your problems. When that doesn't work, how are you going to deal with it? I guess what I'm trying to say is that we all want to kind of think in an agile fashion. So I'm going to do a small thing, see if it works, and see how that goes. But there's a lot of big decisions you have to make up front. So when I'm not writing software for a mythical computer in the sky, but I'm actually writing software for real hardware, which programming language am I going to use? If I use Java, like say I use a JVM language, it probably doesn't matter exactly which one. Do I know how to deploy that? Do I know how to maintain it? Do I know how to make sure that the security updates are applied to my server because Java's got one every 3 weeks, something like that? There was a really bad one just recently, wasn't there? If I decide not to go down the Java route and go for Ruby, same question, you know. I need to decide my operating system. I'm going to run on, even if I'm decided I'm just going to run on Amazon because that solves all the problems. Am I going to run on Amazon Linux? Am I going to run on Ubuntu? Am I going to run on Red Hat or CentOS? Or what's it going to be? I have to decide my database. I love this idea that came from Uncle Bob, well, over and over again, that you just write to in-memory stuff and then put the database in later. Like your database doesn't influence how you model things. Like you can just go, oh, I feel like using a graph database now, so I'm just going to flip it over and use a graph database instead of a relational one. That'll probably work. I tried it, it doesn't. So which cloud provider are you going to use, assuming you're going to use a cloud provider? Or are you going to run on your own servers? Are you going to buy some servers and put them somewhere? Where are you going to get them from? Which cloud provider are you going to use? Are you going to use, Amazon provides a lot of nice services, so does Rackspace, so do all the others. Are you going to use them? Because if you do, then suddenly you've locked yourself into that one provider. And then you have to understand how they work and how they fail. So there's all sorts of problems, and you can mitigate those. But what that means is, as soon as you write a single line of code, you've incurred a mountain of infrastructural debt, because you write a hello world, but where's it going to go? How are you going to maintain it? How are you going to support it? How are your users going to always be able to access it? I'm assuming you're writing some kind of server application, because that's what we all do now. But even if you're writing an iPhone app or something like that, as soon as you write that first iPhone app, if you're not able to get it through the App Store, and that's a huge process, believe me, then you have a load of stuff that you suddenly need to tackle, and it goes from being, oh, I just wrote a Hello World app, it took me 5 minutes to, it's going to take me 4 weeks to really do this thing. Right? So that's the rant part of my talk. Let's see, what was the rest of it? I can't remember. Oh yeah, so there is kind of silver lining to this. I've just mentioned a ton of stuff. I didn't even mention logging. Logging is really important. Please log. You don't have to do all of it up front. Just like we don't have to write the most perfect software up front. We don't have to write the most performant software up front. We don't have to write something that works, end to end and everything is magical. Now, I've seen that price at the back of the room. The walking skeleton is a fantastic idea that does help you solve these problems by introducing you to all your infrastructural problems right at the start. And it does this by basically saying, unless you're in production, you haven't started. So concept is, for those who aren't aware, so you write some code, and you write the barest minimum piece of code. The point is that you get a binary, somehow. It doesn't have to be automated, but you get a binary. It goes onto a server. It communicates. You probably have more than one of these things, so it communicates with all the other servers that you have. And excuse me. And you know that at least infrastructurally, everything is kind of connected. It may not be doing exactly what you want, but you know that you've identified probably all of the risks related to infrastructure that you're going to encounter, apart from one, which I find really interesting, which is when I get more than 2 users, will this explode? Because you probably never tested for that one. Now, conveniently, there are ways to test that now, and I've seen a lot of people writing tests that run in production, which I think is an awesome idea. I see Unruly here doing a lot of monitoring of their environments just to make sure everything is okay, and even monitoring first, which I think is fantastic. So there are mitigations. The walking skeleton gets us part of the way there, but it doesn't allow us to. It doesn't make those decisions for us. We have to make them. And one of the things I think it doesn't do is help us really identify what those risks might be. We still have to have enough experience to know, well, databases are finicky, so I should probably make sure I can connect to a database and write stuff to it before I do anything else. And, well, I really do want to run this as 2 services for some reason. I like splitting my software into 2, so it's really, really complicated. So I do want to run this as 2 services, so I should make sure they can interact correctly and that they can behave correctly when one of them is down. There's all sorts of questions along those lines. But eventually, you're going to create your walking skeleton, and you're going to think it works, and then you're going to start writing some features. And finally, the business people in your business will be like, oh, finally, they're doing some actual work. They're not just playing with computers and making computers talk to other computers. Now we can actually use something. And then you quickly find that you missed something. So in the case, in the project I'm working on, we thought we'd done the walking skeleton, but because we weren't deploying to a machine outside the cluster, which is actually what we needed to do for production, so there was a build cluster and an actual production cluster, and we weren't deploying across, and that got really, really complicated. So we missed something. I should probably ask if there's any questions, but it's really hard to ask questions when someone's just ranting at you for 10 straight minutes, so I can kind of understand. So we go, oh, okay, there's a load of infrastructural work that we need to do. Let's just start doing it. And then a day later, someone goes, how's the progress on that story going? And go, we ran into a bit of a snag, and we're doing this other thing right now. And they say, okay, cool. And then the next day at your morning stand-up, they go, so how's the progress going? Oh, we're still playing with this infrastructure. We don't really know what's happening. And 4 days later, you're still playing with infrastructure, and your product owner or whoever it might be is getting really antsy, not because they don't trust you to do a good job, but because they have no idea what you're doing. Just no clue. And even when you explain it to them, they still have no idea what you're doing because you're using a different language. So that's a problem. So you learn from this lesson, and you go, oh, if there's infrastructural work to do, we should probably actually stick that on our pretty Kanban board using Post-its or whatever it is you use. We started with Jira. Don't ever use Jira. So we use Post-its now. It's fine. So you start sticking these tasks on, and then you have a story, and we like to break our stories down into tasks. So I just give you an idea of the way we do it. So we've got kind of, your standard Kanban board, and we've got these stories, and then we'd like to break them down, and you've got these columns for, I think most people are used to this, but in case you're not used to it, we move one of these tasks over, and we do that one, and then we move it over again to done when we're done, and then we move the next one over. And actually what happens when this happens is you go, it turns out there's some infra work to do, so we're going to add a post-it. And then you go, and that's also being done, but the other one's still being done because you're kind of halfway through it. And then you start looking into it a bit more, but you don't really understand your infrastructure because you're a developer, not a sysadmin. Although you forgot that when you put on your DevOps hat. And then you go, oh, I didn't realize that also depends on that. And then you go, oh, that. And then this story that was 5 tasks turns into a story that's 50 tasks. And your business person, again, is quite mad at you. So you go, okay, I'll learn from this lesson. What I'll do is, if it starts looking like a hairy thing, and it takes more, I'll time box it, I'll take half a day, and if it takes more than half a day, I'll just say, right, this is a separate story, we're doing a separate story. So you now have an infrastructure story. And then you say to your business analyst, or your product owner, or whoever it is that does this, we've got this infra story to do, and there's all this feature work to do, so can you prioritize this stuff? And they go, well, that one's right at the bottom, because I have no idea what it is. And this stuff, I know what it is. So you go along for 2 weeks, and then something breaks, and they say, why did it break? And you go, because we didn't do that infrastructure story. And they say, why did you not tell me? What is wrong with you? Why did you think I wanted our application to break? I just did a demo of it to 27 investors. I was trying to raise 4 million quid, and and it exploded, and now they hate me. And you apologize, and you take them out for a beer, and you say, all right, okay, I can solve this one. All right, what we're going to do is we're going to take our infrastructure story, but instead of writing fix server X so it doesn't explode when Y, I'm going to write ensure continuous running of the application to make sure that our users are happy. And on the back, you'll write down what the actual solution is. And your business person likes that, and they prioritize it. And also, they know to prioritize infrastructure stories now because the last one exploded because they didn't do it. And they kind of learned a lesson too there, which is to probably ask the developers if they don't understand, rather than just going, it's probably not important. So, okay, good. So now we have a process for getting infrastructure work in. The problem is there's a lot of infrastructure work, and we haven't solved that problem. Right, and the problem is you have no idea what you're doing. Because you're a developer and you never learn how networks work or how software talks, how software runs. So you understand that when you run Java -jar and then you give it a jar, it runs that jar. What you don't understand is when that's been running for a while, how the garbage collector likes to behave and how to make sure that it was actually run with the correct switches, and how to make sure that when you have 8 Java processes, oh, here's a fun one. How to make sure that if you run stuff inside a Docker container, this actually happened to us, you haven't capped the Docker container to half the size of the max heap size, so Java never garbage collects, it just dies. You can do that. That's the thing you can do. And yeah, so I'm learning infrastructure too. So I say so a lot. Where was I? Okay, you don't know what you're doing. So so you go, okay, solution, I'll go learn some stuff. So you start reading about infrastructure work, you start reading about networking, you start reading about process management, about how Linux behaves or Windows behaves when you leave it up for a long time. And then you go, that's really hard to get a server running for a long time. So you go for the developer mode thing. I think it was Chad Fowler who came up with the term immutable infrastructure or immutable servers, which basically means never ever update a server, just tear it down and build a new one, which I love and all developers love, because it's just so much easier conceptually to think about a thing that is only up for a certain period of time and then you throw it away and make a new one. The problem is you didn't have zero downtime, so you tried that and all your users got angry. So then you went and built zero downtime into your process, and that spawned a load of new stories and your BA got angry again. And I think where I'm getting at, I'm getting to a point, I think, is developers like to solve stuff with automation, which I think is fantastic. And it really takes someone, I think, to take a step back and go, should we be automating everything, to often understand the real problem. So when we look at stuff like TDD, TDD was about a lot of things, but I was going to say about this, and I knew some people would throw something at me and go, no, it isn't. That's not what TDD is about. So I'm going to say one of the things that TDD is about is putting clients first. So you have a function. You don't just go write the function. You drive the function from your tests, which actually explain how you how this function is going to be used, and then you go write the implementation of the function, which means it's client focused. And then you have kind of the outside-in approach of TDD, which is even more client focused, because you're not just driving it from the tests, you're driving it from the actual things that use it. So you go build the outer layer of your application, that talks to something in the inner layer, and only then do you test drive the inner parts of it. And then you have something like BDD. Jason Gorman's not here, so I won't hear a spitting noise. So BDD, kind of one of the things it does, I was going to say again, the thing BDD does, and someone will get angry. So BDD looks at TDD and says, well, client-focused development is great, but users are kind of special. They're not just other functions. They have needs and emotions and other things that your code probably doesn't have. So maybe we should treat those specially and really try and drive stuff from the point of view of a user. And I've seen BDD work with other systems as well. You know, System A wants to connect to System B, and you know, the BDD style approach can work for that. And that kind of got me thinking, because I think the core thing there is not specifically client-focused stuff or user-focused stuff, but really, to me, it's about interfaces. So, as a software developer, I should be building stuff to conform to the interfaces that I really want to set out. And those interfaces might be a human being poking stuff on a screen, or they might be another server connecting, or they might be the way I connect to my database. And that's really, that's just as complicated as another human being sometimes. I don't know if you've ever tried to use Cassandra, but it's often far more complicated than any human being I've ever encountered, especially when you have lots of nodes spread across availability zones and servers. Basically, it just likes to choke. So I really wanted to start looking at interfaces and start designing my software from the interfaces first. And I think a lot of people do this, but often they do it unconsciously and they don't actually evaluate what every single interface is before they start work. They go, all right, this is pretty user focused, so I'm going to drive it from the user point of view. And that's great. I want to add. So I'm writing Twitter, and I want to say, okay, I want links to be clickable in Twitter. Fantastic. It's a very user-focused thing. I already have the data. I already have links. I just want them to be clickable. So I drive that from the user. But how does that interact with the web browser? And how does that interact with the code that I'm sending, the data that I'm sending from server to client? There's a lot of things. There's a lot of interaction layers, and there's a lot of interfaces, even in that very, very simple requirement that often you don't consider ahead of time. Do I want to store links specially in my database? Do I want to, if I want to store them specially in my database, and my database is a distributed one, how do I make sure they're propagated correctly? And all those sorts of requirements you never really think about. Do I want to store links in a separate service? Do I want to put that information somewhere else? And then how do I make sure that if I can't get a link because that service is down, can I actually still serve up a tweet just without the links? I made this one up, but you get the point. And I guess that's all I'm getting at is we often drive stuff from the user point of view, and I think that's really important. I really like the idea of actually building stuff for people rather than building stuff for programmers, because programmers are idiots. No offense. But we also have to build stuff that, alienates the room. Brilliant. And I think I kind of got my point across, right? So you got to build your software for everything it interacts with, not just the people. Otherwise, you're screwed.